Alright, so we're on question 17 of final exam practice, and in this question we want to find the length and the slope of the tangent to the polar curve r equals 2 sine theta for the values of theta between 0 and pi. So to do this, let's first find the length. So I know that my length is equal to the integral of the arc length, differential of arc length. So I'll write down the differential of arc length for a polar curve. So this is equal to square root of r squared plus the derivative of r with respect to theta squared. Take the square root of that times d theta. Okay, so we have r already. That's not very difficult. Let's figure out what dr by d theta is equal to. So this is going to be 2 times cosine theta, right, because r is 2 sine theta. Either way, I write down r squared is 4 sine squared theta. Dr d theta is 2 cosine theta, so when I square that I get 4 cosine squared theta. Take the square root and do d theta, and this is my differential of arc length. So now I have a common factor of 4. I take it out, but there's a square root, so it comes out as a 2. And then I'm left with a sine squared theta plus a cosine squared theta. And that equals 1, of course, and so square root of 1 is 1, and this just equals 2 d theta. How easy is that? Let's compute this arc length. So I'm computing from 0 to pi, so theta goes from 0 to pi. I'm integrating 2 with respect to theta, so this is just 2 theta integrating from 0 to pi. So when I plug in pi, I get 2 pi. Evaluating at 0, I get 0, and so this is my length. And so of course that makes sense, because if you graph this, you'll see that it's actually a circle with radius 1 or diameter 2. So either way, now we want the slope of the tangent line at each point. And so just like before, we want to compute dy by dx. Okay, but y and x both depend on theta. I can write those equations down in just a second. So what we're going to do is dy by d theta divided by dx by d theta. And so the way that x and y are depending on theta in this case is we know that x is equal to r cosine theta. And so r we know is equal to 2 sine theta, so this is 2 sine theta cosine theta. Okay, so this is what x is equal to. I ultimately want to differentiate that with respect to x and throw it in the denominator here. Y is equal to r sine theta. So of course this is 2 sine squared theta. And so now I need to differentiate these things with respect to x. Or sorry, with respect to theta, rather. That would make a lot more sense. So I want to differentiate this expression y, so this is 2 sine squared with respect to theta. Okay, so this is going to be 4 sine theta, so power comes down, just doing the chain rule. And then I differentiate the inside, so derivative of sine is just cosine. All right, so that's what I get there. And then I do the derivative of x with respect to theta, and I'm going to get 2 derivative of sine is cosine, so I get cosine times cosine, so cosine squared. And then derivative of cosine is minus sine, so there will be a minus 2 sine squared theta. So I can rewrite this as, well, first of all, canceling a factor of 2. I have 2's and a 4, so I'm left with a 2 in the numerator, so I'll write it out front. The numerator is actually, well, rather, actually, instead of throwing the 2 out front, I have 2 sine theta cosine theta, and so I know that this is equal to sine of 2 theta, and then divide by cosine squared minus sine squared, and I actually know that this is equal to cosine of 2 theta. And so then my slope is equal to tangent of 2 theta for each value of theta. All right, so that's the slope of my tangent line for every value of theta.